the most powerful, invisible forces of the universe. The universe appears silent, dark, almost empty. When we look up at the sky, we see scattered points of light, distant stars that reveal only a small fraction of reality. But that image is deceptive because what we see is not what dominates. Most of the universe is made of something we cannot see, something that emits no light and yet determines how galaxies form, how space evolves, and what the ultimate fate of everything will be. To understand this, we must go back to the very beginning. Approximately 13.8 billion years ago, the Big Bang occurred. It was not an explosion in space, but the expansion of space-time itself. In that instant, everything we know today was compressed into an extremely hot and dense state. There were no atoms, no free light, no structures. Only a chaotic mixture of energy and particles. As the universe expanded, it began to cool. Particles formed, then atoms, and over time, the first stars emerged. Those first stars lit up the universe, began producing more complex elements, and gave rise to the first galaxies. But there was a fundamental problem. Visible matter was not enough to explain how those structures formed. Something else was present from the very beginning. Something invisible. That something is dark matter. Dark matter does not emit light, does not reflect it, and cannot be detected directly. But its gravity is everywhere. It was the first to begin organizing the universe. After the Big Bang, it started to cluster, forming a vast network, an invisible structure that stretches across the entire cosmos. This network is known as the cosmic web. At the Nikaikan where this web concentrates, gravity becomes stronger, and that is where visible matter began to accumulate. That is how galaxies were born. Our galaxy, the Milky Way, exists within one of these enormous halos of dark matter. And within that galaxy, in one of its spiral arms, lies our solar system. This means that dark matter made possible the environment in which our sun was born. Without dark matter, the galaxy would not have the structure it has. Without that structure, the conditions for forming planetary systems like ours would not exist. And yet, within our solar system, dark matter has almost no influence. Here, the sun's gravity dominates, keeping the planets in their orbits. Dark matter built the stage, but it does not direct what happens within it. Inside those galaxies, another force comes into play. Gravity taken to its extreme. Black holes.
Black holes form when a very massive star runs out of fuel and collapses under its own gravity. That collapse is so intense that all its mass becomes concentrated in an extremely small region, creating a place from which nothing can escape. Not even light. At the boundary of that region lies the event horizon, the point of no return. But black holes are not only endings. They are also fundamental actors in the evolution of the universe. At the center of most galaxies, including our own, there is a supermassive black hole. In the case of the Milky Way, it is Sagittarius A*, an object with millions of times the mass of the Sun. Although its presence may seem threatening, we are about 26,000 light-years away. At that scale, its influence on our solar system is practically non-existent. Earth does not orbit that black hole. It orbits the Sun. Black holes are not cosmic vacuum cleaners that devour everything indiscriminately. Their influence depends on distance. At a galactic level, they regulate star formation, redistribute energy, and shape the evolution of galaxies. But in our environment, we live in a stable region.
For billions of years, these forces, dark matter and gravity, dominated the evolution of the universe. Thanks to them, galaxies, stars, and planetary systems formed. But something changed. The universe is not slowing down. It is accelerating. Galaxies are moving away from each other faster and faster. Not because they are traveling through space, but because space itself is expanding. The cause of this acceleration is what we call dark energy. Dark energy does not attract. It does not form structures. It does not bind. It does the opposite. It separates. It is a property of space itself, a kind of energy inherent to the vacuum that drives the expansion of the universe. As the universe grows, dark energy becomes increasingly dominant. Today, it makes up most of the cosmos. But its effect is not felt at every scale. Within a galaxy, gravity is still stronger. Within a solar system, the influence of dark energy is practically non-existent. It does not affect Earth's orbit. It does not affect the Sun. But it is defining the fate of the universe.
These three forces do not act in isolation. Dark matter builds the structure. Gravity, including black holes, organizes that structure. Dark energy is pulling it apart. It is a dynamic balance, a constant tension between opposing forces. One builds, another organizes, and another pushes everything toward separation. And from that balance, the universe we know emerges. Now, what does all of this mean for us? What awaits Earth? What awaits life? To answer that, we must look toward the future. In about 1 billion years, the Sun will begin to slowly increase its luminosity. This will cause a gradual warming of Earth, altering the climate and making life as we know it increasingly difficult. In approximately 5 billion years, the Sun will enter its red giant phase. It will expand enormously, possibly engulfing the inner planets, including Earth, or at the very least, completely destroying its habitable conditions. Our planet will cease to exist as we know it.
But that is only the beginning. On much larger scales, dark energy will continue to separate galaxies. In tens of billions of years, other galaxies will become invisible from ours. The observable universe will shrink. Over time, stars will stop forming. Existing ones will fade away. The universe will become darker, colder, quieter. In an extremely distant future, a state known as heat death may be reached, where all energy is evenly distributed and no processes remain capable of generating structure or life. Everything we know will disappear. And yet, all of this happens on timescales so vast that for us, it is practically eternal. Our existence occurs in a tiny instant within that story. A brief moment. In a universe that has been evolving for billions of years. And will continue to do so for many more. And perhaps that is the deepest reflection.
We are not at the center of the universe. We do not control its forces. We do not determine its destiny. But we can understand it. We can observe it. We can ask ourselves why it exists and why we are here. Because in the midst of all this immensity, of all these invisible forces, of all this inconceivable time, there is something extraordinary. Consciousness. The ability to look at the universe and realize that it exists. And perhaps that is the most important thing of all. The universe does not need to be observed to exist. But we need to understand it. To understand who we are.
After exploring the origin of the universe, understanding the invisible forces that govern it, and looking toward its farthest future, an inevitable question arises. A question that has accompanied humanity forever. What does all of this mean? Science has allowed us to understand how the universe works with astonishing precision. It has shown us that we are not the center of anything, that we live in a small region of a galaxy among billions, in a universe that expands and evolves without stopping. It has revealed laws, structures, patterns. It has shown us that the universe is coherent, ordered, and deeply understandable. But science answers the how, not necessarily the why. Why do these laws exist? Why does the universe have the properties it has? Why is there something, instead of nothing? This is where science meets another dimension of human thought. Philosophy. And also, the idea of God. For some, God is an explanation. For others, an interpretation. For others still, a personal experience. And for science, it is not a concept that can be measured, proven, or dismissed. Not because it is unimportant, but because it belongs to a different kind of question. Throughout history, many of the greatest scientists saw no contradiction between studying the universe and believing in something deeper behind it. On the contrary, for them, understanding the universe was a way of approaching something greater.
Not necessarily a defined figure, but an order, an intelligence, an ultimate reason. Other scientists, however, believe the universe can be fully explained through its own laws, without the need for an external cause. And both perspectives coexist, because science does not seek to impose belief. It seeks to understand. And in that process, it leaves room for interpretation. What is clear is this: we live in a universe that functions with extraordinary precision. Where small variations in its initial conditions would have prevented the formation of galaxies, stars, or life. A universe where physical constants appear finely tuned. For some, this is coincidence. For others, it is evidence of something more. But regardless of interpretation, there is something that does not change. Awe. Because the more we understand the universe, the deeper the mystery becomes. And perhaps that is the most important connection. Not between science and religion, but between knowledge and consciousness. The fact that we can look at the universe, analyze it, understand it, and at the same time ask what it all means. Perhaps the question of God is not a scientific answer, but it is a natural consequence of understanding the universe. Because when we see its scale, its complexity, its depth, it becomes inevitable to ask whether all of this is simply the result of laws, or whether those laws themselves have a deeper origin. And perhaps the answer is not in choosing a single idea, but in accepting that we are still searching, that knowledge never ends, and that every answer opens new questions. Reflection. Perhaps the universe does not exist only to be understood, but so that someone, somewhere within it, can ask why it exists.
Journey to the End of Time.
The Holocene has ended. What we do now and in the next few years will profoundly affect the next few thousand years. The only conditions modern humans have ever known so far are changing, and changing fast.
Nothing stays the same on this planet. Everything changes. The Earth is going into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always jumping. Things move on this planet. Things are not still. Everything is turning.
it begins to run out of fuel, the sun won't simply fade away to nothing. Its core will collapse, and the extra heat this generates will cause its outer layers to expand. The sun is now dead. Its remains slowly cooling in the freezing temperatures of deep space. The fate of the sun is the same as for all stars. One day, they must all eventually die, and the cosmos will be plunged into eternal night.
All stars eventually will run out of fuel. The temperature of the universe drops. The stars, one by one, in the night sky, will turn off. And there'll be no more new stars created. And so that the universe will end not with a bang, but with a whimper. And not in fire, but in ice.
With no fuel left to burn, a white dwarf's faint glow comes from the last residual heat from its extinguished furnace. Looking at it from where the Earth is now, it would only generate the same amount of light as the full moon on a clear night. The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes.
In some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future.
A black dwarf will be the final fate of those last stars, white dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter, little more than the ashes of stars. Their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun. Stars take so long to reach this point. we believe there are currently no black dwarfs in the universe.
We have a pace of life that's based on really the energy available to us now. You could imagine living conscious systems which have a very different pace and therefore can extend out at least a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal. Even if our life dies out, one could imagine at some time arbitrarily far in the future, a fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence.
Proton, one of the fundamental building blocks of atomic matter, of what makes us up, can just spontaneously fall apart.
Any material that evades the pull of a black hole eventually dies away as its protons disintegrate.
The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind.
With the black dwarfs gone, there won't be a single atom of matter left. All that will remain of our once rich cosmos will be particles of light and black holes.
It's a bright window in the universe's adolescence, during which life is possible. But it's a window that doesn't stay open for long. As a fraction of the lifespan of the universe, as measured from its beginning to the evaporation of the last black hole, life, as we know it, is only possible for 1,000th of a billion billionth of a percent.
Black holes become the fundamental building block of the universe. A galaxy will basically be a supermassive black hole in a center with smaller black holes orbiting it.
Zombie galaxies filled with black holes continue to evolve.
They'll eat each other and they'll get bigger, and maybe they'll fall into the supermassive black hole and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales you're talking about are now trillions of years instead of thousands or millions of years.
Black holes can bang on space-time like mallets on a drum. And they have a very characteristic song. Imagine two black holes that have lived a long life together. At the end of their lives, they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time. Space squeezes and stretches as it emanates out from these black holes banging on the universe. Those are the gravitational waves. They are literally the sounds of space ringing. And they will travel out from these black holes at the speed of light as they ring down and coalesce to one spinning, quiet black hole. If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound. Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close. As it falls in, it gets faster and it gets louder.
Scientists used to think black holes were immortal, but even these will one day die.
Now we're talking about timescales of unimaginable length, quadrillions of years into the future. On that timescale, even the black holes begin to evaporate.
According to quantum mechanics, space is filled with virtual particles, and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole.
Philosophers and poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control. And the universe, we think, will die in ice. Trillions upon trillions of years from now.
Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, or whatever, there is still energy, even in the space itself. And this energy, according to Einstein, exerts a push on the universe.
What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe. Almost 3/4 of the matter-energy content of the universe is this dark energy. And we don't know what it is.
Dark energy, unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future.
So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever. Faster and faster and faster with time. A runaway universe.
70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future as it might be. We don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future. We won't even understand our own origins, and that's why we want to know and study this subject.
infinity universe. But then, of course, we have to ask, could that end lead to a new beginning? And there are ideas whereby what actually is the end of our universe could in some sense be linked to the beginning of a new one.
We've worked out the mathematics, the equations. They seem to say that if you have an atom smasher that can concentrate tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe. Facing the death of everything there is, this perhaps is their only possibility of escape. And this also raises a very intriguing possibility, sheer speculation of course, that perhaps any universe that has intelligent life in it will create baby universes, will create lifeboats, and proliferate child universes. So an evolution may take among universes in the multiverse. Survival of the fittest may take place. So those universes which do not have intelligent life are infertile. They have no children. But those universes that have mild temperatures, stars like us, would create civilizations that could open up child universes, and they would then proliferate.
After an unimaginable length of time, even the black holes will have evaporated, and the universe will be nothing but a sea of photons gradually tending towards the same temperature as the expansion of the universe cools them towards absolute zero. Once the very last remnants of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end. For the first time in its life, the universe will be permanent and unchanging. Entropy finally stops increasing because the cosmos cannot get any more disordered. Nothing happens, and it keeps not happening forever.